All right, everyone. Hello and welcome back to Physics 40C. Today I wanted to take our second look at electric potentials and then start relating them to parallel plate capacitors. So just to kind of refresh everyone's memory, I wrote down some of the most important terms and topics for electric potential and things to keep in mind. So the first one is this rule of thumb that for positive charges, the electric potential, or U electric in this case, decreases with the direction of the E field. And then for the opposite situation, negative charges, the potential energy tends to increase. And so this actually highlights the most important concept that I wanted to remind you of is that electric potential and electric potential energy are not the same thing. So though they might sound similar, they have completely different equations and they do relate to one another, but kind of getting them confused is probably one of the most common mistakes that I see. So electric potential is the newer term that we've just been introduced to. So we have this new term V, which is volts, and it's given as the potential energy, the electric potential energy of Q plus some source over the charge value. And so potential energy, as we see here, is related to U naught plus QES. And so that would be U once more, U electric. So usually with the U term, it goes to zero because we just take, the potential energy before you've added any potential energy should be zero. Sometimes it isn't, so you have to pay attention to the problems, but most of the time we'll just take that to be zero. Conservation of energy still applies in this situation. So potential energy plus kinetic energy at the beginning is equal to the potential energy and kinetic energy at the end. Okay, and kinetic energy has the same value that it did for physics 40A, which is that 1/2 mv squared number. So the only difference is potential energy now having this new equation value. So that's PE. So for relating electric potential to potential energy, the first equation we have is this one right here. And then to continue on with the different relationships, I wanted to go back. So to further relate the two, electric potential and potential energy electric, or electric potential energy, let me write that out. So you have E potential versus E potential energy. So even writing them, they look very, very similar. But we have to remember that this is a unit of V, which is equal to joules per coulomb, or per unit charge. Oops. And then we have electric potential energy being this U, which has units of joules. Okay, so as the units might hint at, the relationship between the two is going to be V is the U potential over charge. But for parallel plate capacitors, it becomes a little bit more complicated. Sorry. Q plus source. Because you have to think of the voltage or the potential being a potential difference between two things. So just to kind of redraw what most parallel plate capacitors will look like, they are three-dimensional typically, but if you look at them in the two-dimensional plane, it can be a little bit easier. So you have negative charges over here and positive charges over here. And one of the most common sources or things to be providing that difference in charge is some kind of battery. So we can use just V here. So if we connected these two plates to each other using the battery, they would essentially create a difference in E field between them. So we have, in this case, would be our, this charge would be then 0, and then this charge would be positive V. So sometimes people ask me why not positive V and negative V, because that makes more sense to them. But if you think of the change in voltage of a capacitor to be the voltage positive minus the voltage negative, then for the negative plate to be negative V, the actual charge would have to be 2. And in this case, it just can get a little bit more confusing the more you think of it that way. So we tend to think of it as 0 and positive V unless told otherwise. So this equation right here is actually one of the beginnings to figuring out the voltage of a capacitor. So the C is for capacitor in this sense. And then we're also told that it is V, delta VC is equal to E times D. And so the distance that the E field has to travel between the two capacitor plates is what dictates the strength of the charge. If the capacitor plates are really close together, which they often are, the voltage difference can be very, very high. So these are the E field lines going this direction and the distance between them. So this is kind of the very basics to get started on the voltage of the different capacitor or in a parallel plate capacitor. If you have any questions that come up as you look at the lectures, please don't hesitate to come to SI sessions. They're in the description box below. And thank you so much for coming, and we'll see you in both sessions and lecture.